Hi everybody. In today's video, we are going to solve another problem live on LeetCode. Let us pick a problem of easy difficulty today. I have it filtered by easy difficulty level already. Uh, the next one that we should solve is Roman to integer. If you haven't checked out my videos on other problems that I have solved on my channel, please feel free to do so. Okay, so Roman to integer. Well, it seems pretty self-explanatory what it wants us to do, but let's still read all the details of the problem and make sure we understand them. Okay, Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. Okay, these are their values in decimal. I is 1, V is 5, then 10, 50, 100, 500, and 1000 respectively. Okay, for example, 2 is written as II in Roman numeral, just two ones added together. 12 is written as XII, which is simply X plus II. The number 27 is written as XXVII, which is XX plus V plus II. Okay, yeah, that all are very straightforward examples. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not III. Instead, the number 4 is written as IV. Because the 1 is before the 5 is subtracted, making 4. Yeah, we know this about Roman numbers. The same principle applies to the number 9, which is written as IX and not VIII. There are 6 instances where subtraction is used. Okay, so this is important because I don't remember all the specific cases where subtraction should be done, so they have given it specifically. I can be placed before a V or before an X. Yeah, so IV will be 4 and IX will be 9. X can be placed before an L, that makes it 40, XL, or it can be placed before a C, so XC makes it 90. And the last one is that, or the last pair is that C can be placed before D, so that makes it 400, or C can be placed before an M, which makes it 900. Okay, that's makes sense, and it is good. They have given specifically the cases where we need to handle the case specially. Okay, given a Roman numeral, convert it to an integer. Okay, let's look at examples. First one is straightforward. I is 3. Second one is L, B, I. Yeah, actually, this is also not the special case because it just keeps on decreasing or equal, like L is 50, V is 5, 55 plus 358. Okay, so the last one is MCM, XCIV. Yeah, okay, so this is interesting. So the first term is 1,000. The next C, because it is followed by an M, C will be subtracted from M, so that makes it 900. Okay, XC is same, like we need to subtract X from C, so that makes it 90, and then IV is 4, right? So that gives us 1994. Okay. The constraints are that the length of the string is between 1 and 15 inclusive, okay, and it only contains the valid characters. Yeah, basically all upper cases, we don't need to handle the lower case and kind of be case insensitive. So that's good. It's allows us to just simply handle all the uppercase. And it is guaranteed that S is a valid Roman numeral in the range 1 to 3999. Okay, actually this constraint is quite helpful because to simplify our code, because if I remember correctly, I've solved a Roman number problem in some form or shape many years ago, is that the full validity check of Roman numbers is actually quite tedious. It's not hard, but it's just tedious. Like there are so many cases where it's just not valid and you kind of have to code all of that up and gracefully handle them. For example, I think if you are given VIII, that's 8 and that's allowed. But if that is followed by an X, that's not allowed because X is bigger than 8, I guess. That's why it's not allowed or something like that. Anyway, for this problem, we don't have to worry about it. They are saying that we can assume the input is a valid Roman number. Okay, that's great. So, okay, so let's figure out how to solve this. Now, I mean, it's pretty straightforward, so there is no complicated algorithm, but even for such problems, it is good to figure out some details of how we will write the code before we jump into the code. That way we don't end up churning a lot when coding, and especially in interviews that can create not a great impression. Okay, so the first thing we need to figure out is how are we going to encode this value of table of values, right? And the thing that we need is that we want to really look up very quickly what the value of a specific character is. Like I is 1 and L is 50, I guess, yeah, 50 and so on. And immediately one might think, okay, let's put all of it in a hash table. And I think that would be a reasonable thought. But I think we need to be a little bit more careful here in choosing the hash table. And the reason is because there are only 7 characters, right? And if we put it in a hash table, even though it's theoretically O of 1, which actually it in practice doesn't perform O of 1 in a lot of cases, but that's beyond the scope of this video. And theoretically O of 1, it has to do a bunch of operations, right? So for example, first thing it has to do is calculate hash code on the input key, which will be a character in this case. So do some math to figure out the hash code. And then after that, it has to modulo that with the size of the internal array. And then after that, it finds the location in the array, but then it has to kind of create a linked list node because external chaining is the most popular way of handling collisions. And then it has to put the value there, right? And so there is, a bit of overhead, constant overhead, but that constant is pretty large, especially when we consider we have only 7 things we need to insert. So I wouldn't go with the hash table. And also the other thing is hash tables will not use minimum amount of memory. If you are storing 7 entries, it's not going to use exactly 7 array locations, right? It will use more than 7. So there is a little bit of extra memory also that hash table needs. So I think in this case it is just best to kind of hard code these values. Like you can either do like a switch case in a helper, or you can do like store 7 things in an array and then scan the array linearly for finding the right character and its corresponding value. For this problem, I think switch case will work completely fine in my opinion. So we'll go with that. Okay, so with that out of the way, what else do we need to figure out? Well, I mean, we have 2 logical cases, right? One is a simple case where, okay, given a character like I, we either need to simply add 1 to the total, or in some special cases, for I, 2 special cases, we need to actually subtract the value of I from the value that is of the next character, and not really dumbly add 1 to the total. So those are the 2 cases. And there are 2 ways of kind of doing this, right? One is like we look ahead. When we have a character like I, or like X or C, those are the ones that sometimes need to be subtracted, sometimes need to be added. We could look ahead and we could say, okay, hey, what is the next one? And then finally figure out like, okay, what do I need to do right when you are at I? Or you could say, okay, I'm just going to add 1 for I and not worry about looking at for now. And in the next iteration, when I look at the next character, if it turns out to be, something I needed to do special, I'll subtract what I added and then adjust in the next one, or look back basically. So either you look back or you look ahead, and both approaches are completely fine. We need to make sure we don't get out of bounds of the array and stuff like that in either of the approach, but otherwise both approaches will work. I think I intuitively somehow slightly prefer look ahead, because it's just like, for once and for all, when we look at a character, we know what we are doing and we just kind of get done with it. Okay, so I'm going to pick that approach, but like I said, you could easily pick the other approach and that should also work. So with that, let's actually first write our helper that will have the switch case. Like I said, I'm going to choose that approach, which will convert like a specific letter into its corresponding decimal value. Let's call it get value. Let's say char ch. Okay. I didn't write switch case too often, even when I was coding very actively, but I believe this is the syntax for switch case. So case I will return 1, and then let me just copy this. I'll try to type this as soon as I can. That's the fun of live coding, right? You guys get to see me do mundane things. This is 10 and that is X, and then I think L is 50. Yep. So 50 is L, and then C is 100, and then D, and then M. Okay. So this is C, D is 500, and M is 1000. Okay. There you go. And I mean, they have already given to us to assume that all characters are valid, but in languages like Java, if you don't return in all code paths, it's going to give a compile error. So let's just add invalid Roman char as the exception here. Okay, so that's our helper, and that's the good thing about writing helper is that if we in the future decide to change the implementation of how we convert char to a decimal value, it stays in this helper, nothing else changes. Okay, probably that was obvious, but anyway. Okay, so now here, of course, we need one variable to total up our decimal value. And like I said, we are doing look ahead. So we don't need to keep track of the previous character, but we will be looking ahead when we are at index I in string, we'll look ahead I plus 1. Okay, so let's do that. Let's write the loop to go through each character in the string. Sorry, I equal to 0, int I equal to 0, I less than s dot length plus I. Okay, so the first thing we'll do is let's get the current character. So cur ch equals s dot char at of I, and then we'll get the current value, right? So cur val equals get value cur ch. Okay, and this is safe to do. We are within bounds. Okay, now the thing is we need to look at the next one, but always we need to we need to check bounds for that. Now one thing we could do is we could actually stop at one less than here what we are stopping now, and that means we will always have one more character. But the thing is, in that case, we'll have to then specially add the decimal value of the last character outside the loop, or we have to do that inside the loop specially anyway. So I don't prefer that approach. I'm still going to stick to the loop right now, but check for bounds when we look for the next character. And the way I'm going to do is I'm going to say next val equal to 0 and only give value to next val if we are within bounds. And I think that will take care of it. Okay, so if I plus 1 is less than s dot length, right? Then I plus 1 is within bounds. In that case, we say next val equals get value of s dot char at I plus 1, right? So we get, and that otherwise next val stays 0, and that's great, right? Okay, so now that we have the current value and the next value, I think the combination of those two will allow us to check for these 6 special cases, right? And in those 6 special cases, we need to subtract, and otherwise we add. Okay, so let's just write those 6 cases in if condition. I don't think it will look too ugly, and I think it probably will be pretty clean and easy to understand, but let's write it out and see how it looks. Okay, so what do? We said current val equal to 1, and there are 2 cases with 1, right? Next val equal to 5 or next val equal to 10. Yeah, so those are the 2 cases where we will subtract, or special cases, right? And then there are 2 more pairs of cases, and that is, I believe we say 10 here, and 50 and 100. Yeah, so 10 can be subtracted from 50 or 100, and the last pair is that uh, we subtract from 1000 and 500 or 500, we subtract 100. So those are the 6 special cases. And in those cases, what we gotta do is we just subtract the next val, or sorry, current val, right, from the total. So total minus equals curval, right? And otherwise we just add curval to the total, right? So we say, sorry about that, else total plus equal to curval. Yep. And we say return total. Yeah, so hopefully that makes sense. So basically, we just figure out whether we need to add the current value or subtract the current value based on whether we are in one of the special cases. And then the next one will automatically add its value or subtract its value and so on. There you go. So I think this should work. Let's actually run through the MCMXCIV example manually ourselves just to make sure. We'll do it a little bit quickly. So, okay, so the first is M. So current character, current CH is M, which will get current val as 1000. And the next val will be within bounds, and the next val is C, and it will not fall in any of these special categories. So we are going to just add 1000 to total. Okay. Then we go to C. So current CH equal to C, and then the current val of that is going to be 100. And the next val is M, and that is 1000. So we do fall into this 100 and 1000 category. And so we will subtract 100 from our total, which is exactly what we want because the next M is going to add itself anyway to the total. And I think it will continue that and keep on working. And we are doing the bounce check. Yeah, we are doing the bounce check. Okay, great. So with that, I'm ready to run. Maybe there is a compiler error or two. We'll see. Oh, cool. No compiler error. So that's great. Okay, so I mean, we could add a lot more test cases, like Roman stuff is very complicated, but I think the easiest thing to do is to submit and let LeetCode run a much bigger suite of test cases. And it will also tell us how we are stacking up. Yeah, how we are stacking up against other successful submissions. So it looks like we are beating 81% of the folks on time and 84 on memory. That's great. Yeah, so hopefully that was straightforward and it was helpful. There's one more note that I would like to add before I end this video, and that is actually, like I said, if we were writing Roman number parsing code in production for real, you would want to write with the full validity checks. And the Roman number validity checks is actually quite tedious, like I said before. And so I wouldn't just extend the approach that I have taken here to that. And the reason is the if conditions and other conditionals and special cases become way harder to keep track of. And it is also very hard to maintain even if you get all the details right in the first place. And I think a better approach to do that would be a state machine, right? And you draw the whole state machine out on a whiteboard or something and make sure, hey, which arrows are going to be error paths. And you can even generate custom errors for various arrows and stuff like that if you wanted to do that. Maybe I'll do that in a future video, but at this point, I think this is good enough. If you like what I'm doing in this channel, please feel free to subscribe to my channel. I'll really appreciate it. It will support me a lot. And like the video. Okay, see you guys next time.